Dear students, today we will discuss electric dipole. What is an electric dipole? Electric dipole, we define it like this. Two equal and opposite charges separated by a finite distance forms an electric dipole. Let us suppose we have two charges. One is minus q charge at A and second is plus q charge at B. These two charges are separated by a distance 2a. This minus q and plus q separated by a finite distance 2a forms an electric dipole. This is called as an electric dipole. यहाँ पर हम एक एग्जाम्पल ले सकते हैं like water or ammonia. These forms electric dipoles. The distance or from A to B or the length from A to B forms dipole length. Then comes electric dipole moment. So first we have discussed electric dipole, and example is of water, H2O, or you can say NH3, ammonia. These are the examples by which we can get an electric dipole. Electric dipole moment. Electric dipole moment, we define it as the product of the magnitude of one of the charge and the distance between two opposite charges. That is, Q is the magnitude of the charge, either plus or minus. These are, we have to take here the magnitude only, into 2a, the distance between minus q to plus q. It forms an electric dipole moment denoted by P. It has a direction. This dipole moment has a direction. It is always taken from minus q to plus q. Minus q, the dipole moment is from minus q charge to plus q charge. Here in physics we take it like this. And it is SI unit is for charge it is Coulomb, for distance it is meter. Coulomb meter is the SI unit for electric dipole moment. Now we discuss here that another topic is to find electric field intensity due to electric dipole on its axial line. Electric field intensity, electric field intensity due to electric dipole on its axial line. This is our topic here. Suppose I will take here an electric dipole, minus q charge here at A, plus q charge at B. Distance from A to B is 2a. O be the center of the dipole. The distance from A to B is known as dipole length, and O is the center of the dipole. Here is the axial line. Now, what is an axial line? Axial line is a line which passes through electric dipole or it remains parallel to the electric dipole. Suppose we take here any point P, where we have to calculate electric field intensity due to this dipole. This point P lies at a distance R from center of the dipole. This OB is nothing but A. OA is also equal to A. Distance from here to here is R. Naturally, at this point P, the electric field intensity will be due to minus Q and it will be due to plus Q. दोनों तरीकों से यहाँ पर इलेक्ट्रिक फील्ड इंटेंसिटी होगी. Electric field intensity due to minus Q charge is EA. We represent it as EA, which is along this way. Because there's a negative charge, electric field line is always towards the negative charge. At this point P, electric field intensity due to plus Q charge is EB. It is along this way. Since it is a positive charge, electric field line will be in outward direction here. So I will write here how much electric field intensity EA at P due to minus Q, then EB at P due to plus Q by using that Coulomb's law. So electric field intensity EA is given by 1/4 pi epsilon naught Q upon EA, distance from this position to this position, that is PA square. Or I will write this as 1/4 pi epsilon naught Q upon this PA is equal to R plus A. R plus A का whole square. This A. Magnitude. And its direction will be, अगर हम इसको in terms of vector लिख देंगे, what will be the direction here? It will be along PA. Along PA. Similarly, electric field intensity EB, it is equal to 1/4 pi epsilon naught Q upon electric field intensity EB at P due to plus Q. It is 1/4 pi epsilon naught Q upon PB square. From this, I will write it as EB is equal to 1/4 pi epsilon naught Q upon PB, distance from here to here. It is R minus A. R minus A whole square. Along BP. Direction ये बनेगी. Net electric field intensity at P due to whole of the dipole is given by this. I will write here. E is equal to, it will be EB minus EA. Why EB minus EA? Because one is towards left electric field intensity and second is towards right. And I am taking here this EB is maybe greater than EA because this is positive charge. Its influence will be more here than this. Therefore, I will write it here as EB minus EA. This was your first. This is your second. You can use first and second in this third. So we can write E is equal to 1/4 pi epsilon naught Q upon R minus A whole square minus 1/4 pi epsilon naught Q upon R plus A whole square. Now we will solve it. So we can write this E equal to Q upon 4 pi epsilon naught कॉमन रख देंगे, अंदर रहेगा 1 upon r minus a whole square minus 1 upon r plus a whole square. Q upon 4 pi epsilon naught. LCM, it will be equal to r square minus a square whole square. इन दोनों का LCM ये निकलेगा. So it will be r plus a whole square here minus r minus a whole square. Or we can write Q upon 4 pi epsilon naught. We open it. R square plus a square plus 2ra minus r square minus a square plus 2ra divided by r square minus a square whole square. Here this and this will go. Q divided by 4 pi epsilon naught. 2ra means 4ra divided by r square minus a square whole square. So we can write it as E is equal to, I will write here this 2aq like this, 2aq into 2r divided by 4 pi epsilon naught r square minus a square whole square. Or we can write E is equal to 2aq is nothing but P, the electric dipole moment which we have defined previously, into 2 into r divided by 4 pi epsilon naught r square minus a square whole square. Since this r is very greater than a, therefore a square can be neglected. A square को neglect करेंगे as compared to r square. So we can write E is equal to 2 into P into R divided by 4 pi epsilon naught. This will become only R power 4. This R and 1R will go, यहाँ पर 3 रहेगा. That means E is equal to 2P divided by 4 pi epsilon naught R cube. अगर वेक्टर दिखा देंगे, E वेक्टर will be here, ये भी डायरेक्शन बनेगा, और टोटल along कहाँ से बनेगा, इलेक्ट्रिक फील्ड इंटेंसिटी, it will be along BP. This implies this electric field intensity E on axial line, I will write this as A as an axial line, is proportional to 1r cube. This means electric field intensity decreases as R goes on increasing. This is all about the electric field intensity due to electric dipole at a point on its axial line. So this is all for today. Okay. So guys, like, share and subscribe my YouTube channel. If you have some queries, you can comment in comment section below.